Hello everyone, this is Dr. Uttam Satpute, Professor Electrical Engineering Department at Dr. D.Y. Patil Pratishthan's College of Engineering, Saurabhikanagar. This is a video on the course Power System Stability and Control, Unit 5, Optimal Power System Operation. Now the course outcome, it is defined number 5, to understand the formulation of unit commitment and economical dispatch task and solve it using optimization technique. Now this course outcome, the rubrics as per the revised Bloom's taxonomy, it is applied, and knowledge category, it is procedural, situation using optimization, criteria minimum cost. Now I have divided this course outcome into course competencies CO51, CO52, CO53, CO54, 5 and 6. Okay, you please go through this course competencies. Now this is the mind map I have prepared just to understand the title of this unit, that is optimal power operation or system operation. Okay, so this is the one. Okay, so this is the unit what we are dealing with now, optimal power system operation. Now, all of you know that power system. What is power system? All we know. Here in power system, we have generation, then we have a transmission, then we have a distribution, and then we have a load. So, this generation to load, the entire system, what we call it as a power system. Now, this power system, now we have to operate. Now, operation, power system operation. Now, how this power system operation? It should be optimal. Now, what is mean by optimal? Optimal means it has, it should be minimum. There should be some parameter. Optimal in generally it means that some parameter in the power system operation, it should be minimum. So based on what parameters to be minimum, we have different type of optimal power system. We have divided into different studies. The first one is optimal power flow. Now the objective of this optimal power flow, it is to have loss, the loss to be minimum here, the transmission loss or it may be distribution loss. So the objective of this optimal power flow, it is minimum loss. The second objective here may be secured operation. I want to operate my power system optimally, and what is the aim? It is to have secured operation. Secured operation we will discuss later on in unit 6. There are different state of operation like normal state, alert state, emergency state, restorative state, and so on. So the power system now, it is to be operated in the normal state. In the normal state, wherein the equality constraints are satisfied as well inequality constraints are also satisfied. So the aim is to operate the power system in a very secure manner, normal state. So we will discuss in more detail in unit 6. The third here, the operation, the power system operation should be reliable. Okay, reliable means what? If there is any fault taken place, if any of the equipment in the power system gets faulty, then even though even though the supply to the consumer to be should not be interrupted. Minimum interruption in spite of any fault taking place. So that is what we call it as a reliable operation of the power system. Now, apart from these three, we have this very important, the fourth objective. It is economical operation. I want to operate my power system so that the system is economical. The total cost, what is unoccurred for generation, transmission, distribution to the load, it should be minimum. So that is what we call it as an economical operation of the power system. Now this economical operation of the power system is divided into two parts. One is economical load scheduling. It is called as load scheduling, and the second one is unit commitment. It's called as unit commitment. We will see these two, economical load scheduling and unit commitment, in this unit 5. Now economical load scheduling, it is further divided. We are doing this with transmission loss and without transmission loss. With transmission loss and without considering transmission loss. In the unit commitment, our syllabus is only restricted to the methods of unit commitment and the constraints that are considered for doing unit commitment. We are not going in detail with unit commitment problem in this syllabus. Now, let us start. As I told that we are now, our interest is economical operation. In the economical operation, this is our first part, that is economical load scheduling. Let's have just the concept of this economical load scheduling. Suppose if I have a transmission network, this is a transmission network, let us take, okay, and we have a load connected to this, and we have generators. Say we have various power plants, idle power plant, thermal power plant, nuclear power plant, or your renewable sources, solar or wind, whatever it is. So these are all plants what I'm showing, and so on. Let us take, I have n number of power plants. Okay. Now these plants here, what I'm considering, it is to be noted that they are fuel based fuel-based power plant. This is very important point to be noted. The power plants what I'm considering, they are fuel-based. Fuel-based means either coal-based, means thermal power plants, or it may be nuclear power plants. So not nuclear I'm considering here. I am considering only coal-based power plants. So here I have shown one power system, and in this power system we have this transmission network, and we have so many generators, and these generators, they are all coal based or thermal based, you can say. Okay, they are all coal based thermal power plants, and this is the load connected. Now what is economical load scheduling? Economical load scheduling means what? Suppose for the given load, we are given certain load. Now this load, it has to be supplied from the generator. So I have to generate PG1 here, I have to generate PG2, I have to generate PG3, and so on up to PGN. Now, how I schedule these loads means what should be the value of PG1, what should be the value of PG2, what should be the value of PG3 up to PGN, so that the total cost is minimum. The total cost of generation is minimum. This is what is the concept of economical load scheduling. So the economical load scheduling, we are trying to reduce the cost of generation, okay, and to supply the load. Now here there is one important point. Now cost. Cost means generally we come into picture that the cost, they are capital cost. There is investment, you can say the investment cost, or investment plus operational cost, or we can say it is running cost, operational cost, or it is running cost. Now here we are considering only operational cost or running cost for doing this economical load scheduling. Now in this operational cost also we have fuel cost, because for thermal power plant we require coal, and coal requires some money. So the coal cost or fuel cost, plus we can say the salary or maintenance cost or salary cost and so on. Total running cost, okay, maintenance cost and so on. माझ्याकडे नाही आहे. कुठं अपलोड करायला? व्हिडिओ करायला तुम्ही असं डिस्टर्ब केला तर कसं काय? So sorry for disturbance. So now here we are considering only operational cost, and in the operational cost we have fuel cost, salary cost plus maintenance cost, and we are considering only fuel cost, and this fuel cost is to be minimum. That is what we call it as economical load schedule. Now before going to this, how we should do the economical load scheduling, what should be the criteria so that the generation can be done, and the fuel cost can be minimum. Let us first understand what is performance curve. Now there are mainly different type of performance curves, but we will deal here only two types. One is called fuel cost curve or heat curve or input output curve. There are different names. Okay. Now here it is shown. Now I will just tell you. Now suppose we have a generator. This is, now I am considering coal based or thermal power plant. Now input, it is the coal, okay, and the output, it is the electrical power. So you can say it is P. Now this coal, now you have, now you can take it, what is the heat? What is the heat of the coal that is burned? That you can take it as an input, or the cost of the coal, that is rupees. How much rupee of coal is required to generate particular amount of power? So heat, or heat that is generated after the coal is burned, or the cost of the coal that is required to be given to thermal power plant for the particular power generation. So this is the input, heat or rupees is the input, and output you can take it as an electrical power. So here it is shown on the x-axis, it is your power that is generated from the plant, and on the y-axis is taken heat, or it is taken as heat. It is in kilocalorie per hour, or the or it is the cost of the coal in rupees per hour. So this can be, it is called as fuel cost curve if you take it in rupees, and the if you take this y-axis in terms of the heat in kilocalorie per hour, then it is called as heat curve. Altogether, it is called as input output curve. So we have to understand that the input here, it is either heat or it is rupees. Okay. If the input is taken as heat, then it is called as heat curve, and if the input is taken the cost of the coal, then it is called as fuel cost curve. So a uh, typical for a particular power plant, this is for the input output curve of a particular thermal power plant, and you can see here this is PG minimum, means this is the minimum power that has to be generated from the power plant, and MW max, this is the maximum power that can be generated from the power plant. And as you increase this power, your cost also increases in this way. It is a quadratic function. Okay, now this is explained here. You can write this if this question asked in the exam. So you can write these statements. Now you have seen that the curve what we have, this it is a quadratic equation, and we can fit it using a second degree polynomial. Second degree polynomial. So here it is written analytical expression for that curve. Ci is the cost of the coal. Okay, half AI half AI PGI square plus BGI plus DI rupees per hour. So this is the cost of this expression will give you this for a particular output power, what will be the cost of the coal per hour. So here PGI is the output power from the ith. I here it indicates that it is from the ith power plant. It is from the ith power plant. So first power plant, second power plant, like that. In plant, one plant, two plant, three plant. Likewise, it is ith plant. So from the ith plant, if you want to generate PG power, then what will be the cost? So if you substitute this value in this equation, then this equation will give you cost, how much cost of coal will be required. It is in rupees per hour. Okay. So and here AI, BI and DI, they are called as coefficients. They are called as coefficients of this equation. So this is called as, to remember that this is called as cost function of the plant. This is called as cost function of the plant. Further, we may require this concept. So the equation, it is called as cost function of the plant. So you have to remember the cost function of the ith plant is Ci is equal to half AI PGI square plus BI PGI plus DI. It is in rupees per hour. Now the next is, this is called as, this is another performance curves, not written here. It is called as incremental cost curve. This is called as incremental cost curve, or you can say it is incremental heat rate curve. Now I will call it as incremental cost curve. Okay, and cost function, just now we have seen the cost function Ci is equal to half AI PGI square plus BI into PGI plus DI. So this is the cost function. Now if you differentiate this equation, suppose if I differentiate this with respect to dPGI, then I get the equation like here. I get the equation, yeah, I'll get the equation as AI into PGI, AI into PGI plus BI. And this is called as incremental cost function, ICI. So here it is written the incremental cost function. So you have to remember that this is incremental cost function. Now it is very simple that the cost curve what we have learned, if you differentiate that, then we will get the incremental cost curve. Here it is shown the incremental cost curve of a typical power plant. Similarly here, let me show you this on x-axis we have the power output, and on the y-axis we have incremental cost. Now the unit for incremental cost is rupees per megawatt hour, because we are differentiating. The cost is rupees per hour, and if you differentiate with respect to power, then we get rupees per megawatt hour. And this dotted line what is there, this is the incremental cost curve, and this dark line whatever is shown, it is uh, okay, no, actually, this is the incremental cost curve, but we can approximate it by this equation. Okay, so this is the incremental cost curve. So here the point to be remembered is the one is what is the fuel cost curve and fuel cost and the cost function. So this function we have to remember. This function we have to remember, and what is incremental cost curve and what is the equation. If you differentiate cost curve, then you will get incremental cost curve. Okay, so in this video up to this only. Thank you very much.